by popular demand from my viewer, yet more critical path questions. Okay, world's easiest precedent table. So we have our start. Then we have an activity, which is K, which takes 13. Then we have another activity, which is L, which takes 5. And then we have another activity, which is M, which takes 16. Hilarious gun joke there. All right, so we know that the whole thing takes 40 minutes. And the instant that Andy takes the activity, Caleb gets a phone call, blah, blah, blah. The maximum time that Caleb can speak on the telephone before he must start his allocated activity is, so basically we want to know what's the latest starting time for this point here. So we know we can take the whole thing can take 40, but if we add up all the numbers, if we add up 13 plus 5 plus 16, you get 34. So you can actually got a float of 6. So to get to this point here, we've got a float of 6, and 13 plus 5 is 18, plus the float of 6 gives us D24. Very important to note here that we're talking about a complete graph with 4 vertices. So what's a complete graph? That's when every vertex is connected to every other vertex. So 1, 2, 3, 4, 5, 6. The answer is 6. Be careful, it's not the case of 1, 2, 3, which is a spanning tree. So complete graph, this is a spanning tree. Make sure you know the difference, and then you don't accidentally choose B. Now, looking at this precedence table, you might be thinking, I'm going to have to do the whole big thing, but you don't have to for this question. It just says, what is the duration of activity B? And since activity C requires A and B, and its earliest starting time is 2, and A takes 1, so I'm pretty certain that B takes 2. Okay, now we need to know what is the EST for D. Is activity D. D needs C. Now C starts at 2 and takes 1, so it's going to be 3 in there. We had a 2 there. There you go. Our answer is 3, and don't forget to say hours. So you want to say 3 hours. There you go. Okay, so far I've resisted drawing a diagram, but looks like I'm going to have to do it. Now, sorry for the slightly bent drawing, but it's not so hard to actually work out the critical path is in fact that path. Did have to put a couple of dummies in there. And there weren't many choices in the whole thing. Like F and H are only 1, whereas G is 4, A is 1, and B is 2. So fairly straightforward. So of activities which could be delayed from C onwards, so we're saying from, let's choose another color, from here to here, what can be delayed? Well, these two, because they're not on the critical path. So the answer is F and H. You might be able to see that from the actual table here, that F, G, and H all have the same immediate predecessor, and this was the biggest one. So that would show you that this and this, because they're 1, they wouldn't be on the critical path. But there you go. Okay, so this is one where we've got a bit of a modification. It says that activity E will now take 4 hours. So where is E? E is here. And again, we said the critical path is like so. So all we've got to do to work out the shortest time to complete the activities. Notice I haven't done any forward or backward scanning. Wasn't necessary. I just got to add up all those numbers. So 2 plus 2 plus 1 is 3 plus 1 is 4 plus 4 is 8, 12, and 13. So the answer is 13 hours. That was quite an easy exam. There you go. Okay, this one's from the 2013 exam, and we've got to insert activity G. It's missing from the diagram. So G says it needs BDH, but we can also see that BDH is also needed for J. So we know where it's going to start, and we're thinking, ooh, is it going to be a dummy? But it's part A, so hopefully not. That's my instinct. Now, if we look here, we need to see what else needs G, and I needs F and G. So it looks like you can satisfy all of that by just drawing a line up like that and saying G, and it's comma 4. There we go. And our diagram is now complete. And that does actually, if you just check it through, so J has not been affected there, still has B, D, and H. And G has B, D, and H, and I does have F and G as immediate predecessors. All good. Okay, let's get the EST of H. Well, look, there's only one way to get to this point, the beginning of H, which is that path. There are no other paths, so it is 7 hours. Okay, so now we need to find the critical path, basically. And it says G is not on the critical path. Hey, that was just to make sure that when people wrote the exam, you weren't going to get in trouble if you'd stuffed up the previous parts. So write down the critical path. Well, we know G is not on the critical path. Yay. And look, there's this horrible 15 up here, which is quite a large number. So just to get to this point is 20. And then following that just straight across, you've already got yourself, what's that, 37? So just adding up the 5, the 15, the 9, and the 8. So is there anything that's going to be more than 37? And I can't really see that happening. You can try other paths. We're just eyeballing this. So to get to this point, what's the longest path? It looks like that, which is 15, right? And we know you're not going through G. So that's 15, 24, 27, 31. And the 3 and the 8 is just the same as the 11. It looks like it is definitely a winner, just through the old iBrain combo attack of saying it is in fact just A, F, I, M. Put some nice little commas there. And the next part is saying find the latest starting time for activity D. So basically we need to work out what the whole float on that system is. So I put the bullet and did the whole critical path analysis, forward and backward scanning, and you can easily see that it backs up that we have a path through here. But if we're trying to find the LST for D, we might be tempted to use this 5, but that's not true. In fact, if you use, because that's actually also for E as well as for D, and that's where we come into our problems, because what you actually see is on that little red number here, 14, that's the one that's on D. And the answer is actually, by the way, 14 hours. And another way to do this is to find the float on D. Now what I'm going to do is first of all use the eraser a lot, get rid of some of my highlights. There we go. And if I just highlight this and this, and imagine you didn't have your little red 14 or you're getting a bit confused. So this is trying to make you a bit more bulletproof on the exam. You can imagine just highlighting that activity. We've got D, 2, and we've got a box at the end and a box at the beginning. And I'll be nice and put the colors for this. So we've got 4, 15, and then we got 5 and 16. Now you can do the float. The float, you can do this one minus this one minus this one. So if you do 16 minus 4 minus 2, you'll get 10. So we know the float for D is 10. And if you've got a float of 10 and you're starting at 4, then the 4 plus the 10 will give you the 14. So that's just to remind you of the other way to do the float. But the trick with this question might be to assume that it was the 5, but that 5 is for E. D has that little red 14. So if you do my technique, you know what the little red one is, just the LST for D. Now, this is a horrible wordy question. It says, consider the following statement. If just one of the activities in this project is crashed by 1 hour, then the minimum time of to complete the entire project will be reduced by 1 hour. Explain the circumstances under which this statement will be true for this project. So if you crash an activity on the critical path, because remember the first rule of crashing is crash the critical path. So that would be any of A, F, I, or M. And that's what they're trying to say in a very convoluted worded sentence. Okay, so it says here, assume activity F is crashed by 2 hours. What will be the minimum completion time for the project? Now you've changed things, so let's go in and do some changes. So 15 becomes 13. That means 20 becomes 18. And now we're comparing 18 to 19. Let me just highlight that. So this 18 is now being compared with 19. And so you can see that actually the 19 is bigger, which means A and F are no longer on the critical path. In fact, we have a new critical path. So let's just work that out. So instead of the 19, I'm going to do it in my lovely dark purple. So it's still critical path through I and M, but if you trace back where that 19 comes from, you'll find it comes back through here. So our new critical path is actually C, E, G, I, M, and I think I've missed H there, C, E, H, G, I, M. So if you add all that up, that's 4 plus 3, which is 7, plus 8, which is 15, plus the 4, there's the 19, plus the 9, which is 28, plus the 8, which is now 36. If you add all that together. So it is now 36 hours. So by crashing by 2 hours, we changed the critical path, as we always check when we crash things, and found that we only reduced the overall project by 1 hour. And that's a part E. It wasn't going to be as easy as 35 hours, was it? Okay, another critical path analysis question. This is from 2014 exam 2. We want the EST of F. I'm just going to do the path comparison method. Here's the beginning of F. You can get there in 7, or you can get there in 5. EST is forward scanning. You choose 7, so the answer is 7 hours. Okay, what is the LST of L? Oh God, I'm going to have to do forward and backward scanning. Now, as I've pointed out before, once you've done your forward and backward scanning, the LST for that particular activity, which is L, is the red number that's just for L, because the 10 here is the 10 for H. And you can see there's a 12 here for I. So the answer is actually 18 hours. And you can see that's just the one for L. Okay, what is the float time of J? I'm going to use the Highland technique because I'm not sure how to do these sometimes. You can get in a mess because of many alternative paths. But I'm just going to highlight that little bit out of the diagram, do a little subgraph. And this is 11, that's 13, that's 13, that's 15. So all I've got to do is the last box minus the first box and the activity duration. So if I do that, it's 15 minus 11 minus 2. 15 minus 11 is 4, minus 2 is 2. The float time is 2 hours. And you could have done it by the difference between these two, but as I've shown in previous videos, that does not always work. Okay, we're adding a new activity X that has no predecessors but must be completed before activity G starts. So it's you got some sort of weird activity diving in here called X, 7. And if you think about it, the path to get to G is this one, which takes 11, but you've only got 7. So what is the latest start time of activity X? Well, you've got a float of 4, so because that's the difference between these two. So it is 4 hours. Okay, so we can crash activity A by up to 4 hours, and it's $90 an hour. Does include the activity X, but we say it's got a float of 4, so it's unlikely to be affected by the whole thing, just to make sure that people don't get confused in the question. And we want to go know the least cost of crashing. Now, our critical path is like this. Now, there are lots of other paths I can draw on the diagram, but I only need to compare the critical path with paths that don't include A. Why is that? Because any path that includes A, including the critical path, will be reduced by the same amount. So only having to look at those ones that don't include A, which, funnily enough, is all the paths that include B. Now, if I take B, I go to here, I can go across here. Now I have a choice of 3 across the middle or 4 and 7. I'm going to go with 4 and 7. I can already see just by a bit of brain power that that orange path is actually has a length of 18. Wrong color there. 18. So it already looks like a difference of 3 but to the critical path. There are other paths I could be looking at. I could be doing a blue path like so, but it doesn't look, I mean, that looks like one of the longer ones in comparison, but it's 5 plus 4, which is 9, plus 2, which is 11, plus 6, which is only 17. It looks to me like the best I can crash is by 3 hours. 3 hours, which equals $270 because 3 times 90. So that's all I did. There are a couple of other paths that involve B, but you'll find they're all much shorter. So we only have to compare to the path that is longest that doesn't have A, and that was the orange path. Okay, what is the EST for D on our diagram below? This is D here, and obviously you only need B before it, so 3. That was straightforward. Okay, what is the LST of D? Well, I'm going to tell you that I'm going to do the path comparing method. This loop, AC, has a total length of 13, and this loop, BD, has a path length of 12. Both incorrect answers that apparently were quite common. But you can see to get to this point, there's a float of 1 for the bottom path, including D. So you could do B of 3 plus 1 of your float would give you the LST, 4. If we're given EST of I is 22, what is the duration of activity H? Well, let's think about it. We know we've got to go this top path, which is 13 because it's longer than the 12. So it's 13 to get to here. It's 22 to get to there. We're going via H, obviously. So going this way, it's going to be 5 plus 8 plus 6 for the F, which is 19. So 19 plus the H equals 22. So therefore, H equals 3 minutes. Well, we've got to write down in order the activities on the critical path. We know that's our critical path. So our activities are A, C, F, H, I. Done. Now this is quite a tricky question. We've got activities C and D that are normally done by separate people, but now they're saying and C and D must be done almost like with C. But weirdly, you can actually sort of say like this, I'm going to change it and make D connect up to here, like so, D, 9, like this. And in that situation, you can actually follow through like this along the graph. And that's our new critical path. It's a very confusing worded way of describing crashing. Now, we chose to put the D going up because the A was 5 and the B is 3. And obviously, you want to get the D started as quickly as possible. Now, if you add up all those numbers, you get 33 minutes. But apparently, that was not enough to answer the question. So you have to say something like an increase by 7 minutes was considered the better answer for the thing. And you might want to mention there's a new critical path because you're comparing it to the 26 minutes. So it was insufficient to simply write an answer of 7 minutes or 33 minutes. You need to reference an increase or new critical path to get your full mark. But that's a very, again, clumsily worded question. Okay, apparently they have this new thing called Seafood Fridays, whereby we've changed activity G, which cannot be started until activity F has been completed. And we need to draw that change without changing any activities or, on the graph below. That means put a dummy in here, if you check that out. So now G has got a new immediate predecessor, which is F, and that's why we've got that little dummy there. Now don't forget H had a value of 3. So what effect does the inclusion of the seafood on Fridays have on our critical path? Well, we knew that critical path used to be like this up to this point, but we got H as 3, G as 5. I'd rather just eyeball it that way because H is shorter path. And so there's just been an increase of 2 minutes. So increase CP by 2 mins to 28 mins. Done.